We started doing the last computing platform revolution, the personal computer revolution, where what used to be Unix workstations migrated to Windows-based workstations. The technology that made it possible for us to collaborate was based on OpenGL. We invented a technology called CGFX, which is the precursor of CUDA. OpenGL became what it is today, fully path-traced and physically based, and CGFX, of course, became CUDA. Here we are working together again as we reinvent the computing platform. Everything that we do is in the digital world. 40 years ago, Dassault revolutionized the idea of virtual twins to represent the physical world in a computer. Now we're going to represent the physical world at a much, much larger scale in a completely revolutionized AI computer, making this a really fantastic time. We're reinventing the computing stack altogether. In the last generation, the representation of designs was structured. We specified every geometry, every material, literally everything. Now it's going to be a generative computing model, and the entire computing stack is being reinvented. Because AI is foundational to every single industry, it is going to become an infrastructure, just as water, electricity, and the internet were infrastructure. We're growing so fast because every single industry needs to build it. Every single country will be powered by it, and literally every society will have it. This is the beginning of a new industrialization, which is fantastic because Dassault is the engine of the representation of everything that you want to build. In the past, we spent a third of our time in design and digital and 2/3 in physical. In the future, it is very likely we're going to spend 100% of the time in digital, and even after we're done designing, simulating, and validating it, we have to integrate it with software. Everything inside Dassault systems, whether it's CATIA, Simulia, Biovia, or Delmia, will be built on top of NVIDIA. The design, representation, simulation, and operations will be software-defined. Everything from a pair of tennis shoes to cars, the robots that build the cars, and the factories where those robots are orchestrated will be software-defined. We'll be designing and operating everything really as a virtual twin. If I were to start all over again, I'd choose to use SolidWorks. Almost everything that we did together starts with the computing platform. When PCs went into the cloud, Dassault reinvented itself, and now, as we extend from cloud to AI, we're reinventing again. Today, we are announcing a massive partnership, the largest collaboration our two companies have ever had. Over a quarter century, Dassault is going to integrate NVIDIA CUDA acceleration libraries, NVIDIA AI for physical and generative AI, and NVIDIA Omniverse, our version of digital twin technologies. All of these libraries represent our body of work over the course of a century. We are fusing these technologies into Dassault, so you will have the benefit of accelerated computing and artificial intelligence, enabling you to work at a scale that's 100 times, 1,000 times, and very soon, 1,000,000 times greater than before. What used to be pre-rendered or offline simulations will now be literally the virtual twin visions you've always had done in real time. We'll design products, simulate them in a wind tunnel, and connect robots operating in a factory building your products all in real time. All of this is going to be happening in the next 5 to 10 years, and it's going to be extraordinary. To compute a world model for life, the first thing we have to do is understand the language of life. In physical design, you represented objects using structured information, geometries, and textures that you designed. However, life existed before us. We have to learn the language of DNA, proteins, and cells, and understand how they interact. That first stage of learning the meaning of life is what we are currently tackling. The second part is generative. Once we learn the meaning, we can translate between human language and the language of biology. Beyond that, we can generate new proteins or chemicals for drugs and generate new materials that are stronger, more heat-resistant, lighter, and easier to manufacture. All of those properties are within our grasp, making this likely one of the most impactful areas of engineering in the next decade. We can't compute infinity, but we can imagine it, which is why the fusion of simulation and artificial intelligence, surrogate and emulation models, is so powerful. 8 years ago, I introduced the idea that we will augment principled physics simulations with generative methods of predicting the future using AI. It's a bit like how dogs catch a ball out of the air. They aren't doing physics simulations of elasticity, they're just predicting where it's going to go. The idea that an AI could learn to accurately predict physics, how materials crumble, or what happens in a crash is within grasp. We have an AI framework called Physics Nemo, a physics-aware model simulation system trained by or working alongside principal simulators. It's grounded in the laws of physics but predicts 10,000 times faster, with everything running in real time, predicting at a 10,000 times greater scale through the combination of simulation and emulation is going to be revolutionary for design. People used to think about designing products first and then building the factory. Now the products you design will be heavily impacted by the factories you build. Every single factory is designed in CAD, but it will soon be simulated and operated completely inside a virtual twin. Operating a gigantic factory of millions of objects inside a virtual twin is extraordinarily complex. We want to simulate how these factories will operate in the real world to properly arrange manufacturing lines, organize the robots, and run the AI so robots can safely manipulate and assemble things. All of this will happen inside a virtual twin. The products Dassault will help build are going to become gigantic systems of objects, AI, and robots coming together, which is exactly why you're going to need fast computers. We are going through a new industrial revolution. Just as mechanical energy, electricity, and the internet did, artificial intelligence is a fundamental technology impacting global productivity. To make this possible, we are industrializing three giant industries: chip and packaging factories, computer factories that output supercomputers, and finally, artificial intelligence factories. These AI factories are incredibly complex. A gigawatt AI factory costs about $50 billion, and we are building tens of gigawatts globally in the largest industrial infrastructure build-out in human history. To ensure these systems, giant data centers with massive power and cooling needs, work the first time, we design, plan, and simulate everything in Dassault before we build. We even run the network and supercomputers inside the virtual twin before breaking ground, saving tons of time and money. Over time, these virtual twins run forever alongside the real data centers, training and updating our models, while AI optimally modulates power and cooling. It looks real, operates effectively, and integrates the entire industrial bill of materials perfectly, preventing any mistakes. One revolutionary aspect of AI is the ability to interchange between structured and unstructured information. We can take unstructured information, like a photograph or video, and use AI to translate a 2D image into a 3D structured representation that is precise, controllable, and interchangeable. We can use AI agents to manage our information and augment the design process. While some think the number of designers and tools will decrease, it's exactly the opposite. Every designer in the future will have a team of AI companions. You'll train them, teach them skills, and act as their manager and architect. You can kick off your team to explore different optimizations, and when they return with various designs, you can fine-tune the structured 3D data yourself. This reinvention of design and creativity is completely revolutionary. To achieve this, we rely on world models. A standard language model understands syntax, vocabulary, and guardrails, but a world model has to obey the laws of physics. It must understand causality, inertia, friction, gravity, and contact. We teach the AI this sensibility, which language alone cannot capture, using laws of physics and simulations. This allows us to shift left, integrating design for manufacturability and compliance upstream. You're constantly obeying the laws of physics and using approved components, so by the time you're done, the design is good to go. Our partnership and what we're announcing today is genuinely extraordinary. The scale of what you will build, 100, 1,000, or 1,000,000 times greater than before, is simply impossible without accelerated computing, real-time simulation, and artificial intelligence. The foundation of our partnership has always been RTX and computer graphics, but we've extended it to CUDA, AI, and Omniverse. NVIDIA's GPUs will revolutionize your tools and how your companies operate. In the future, everything will have AI in the loop. Your AI companion will sit with you, privately codifying your skills, preferences, habits, and domain expertise. CATIA will always be CATIA, and SolidWorks will always be SolidWorks, but they will be built on top of NVIDIA. This ecosystem is going to be amplified by AI right as the world starts a massive industrial reindustrialization, requiring trillions of dollars of infrastructure to be simulated and validated in virtual twins. The vision Dassault had 40 years ago is coming true right now. Without the amazing work this community of engineers and scientists does, our technologies wouldn't have an opportunity to come to life. I want to thank all of you for the incredible things you do, and thank you for a great quarter-century partnership. I am definitely a solid worker. My virtual twin gets to stay home and work.